So let's look at like a fiddly kind of question. 28. So 3 by 3 grid of points. Many triangles can be formed using 3 of the points as shown as vertices. So 3 such triangles are shown below. Of these triangles, of all the possible triangles, how many have 3 sides of different side lengths? So you can see that these triangles are not afraid to pass through other points on their way to their vertices, and so actually the ones that are drawn all have different side lengths. So the answer is at least 3. I guess we're assuming this 3 by 3 grid of points, the points are equally spaced, so that this line is the same distance as that line, same distance as so on. Okay, so if they need to have different lengths, maybe we can classify the different kinds of lengths. Okay, so I did something quickly here. So this is my grid. So the kind of side length you can have with a triangle just sort of this single straight connecting adjacent dots, or this close diagonal. You could also have the long diagonal and the long edge, and then these sort of night lines. Okay, and I think they're the only ones you can have. So there's only like 1, 2, 3, 4, 5 different types of sides. And then I guess I proceeded to bash this problem. Haven't quite had a chance to check it, but you can have a look. So I thought it was very hard to have a triangle with a big diagonal, so I started with that case first. So if you had a big diagonal, okay, I noted that you weren't allowed to do this big triangle because then these two sides would be equal. And we can look for a point on this side to make a triangle, and then however many on that side is just times 2. So I see you can make a triangle like this and down, or you can make a triangle like this and across. So there's only 2 possibilities corresponding the only 2 vertices you can use. And then on the other side there's 2, so altogether there should be 4 with the long diagonal. Okay, and then there should be another 4 corresponding to, so that's 4 corresponding to this diagonal, put 2 on each side, and then should be another 4 corresponding to the other diagonal. Okay, so for diagonal, so this should be 8. Okay, now if we consider the long side on the edge, this kind of line is the side of the triangle. We can't, so once we got an edge, we just need to pick another vertex to get a triangle, and we can't pick the vertex on the middle, on the line of symmetry here, because that'll give you an isosceles triangle. So we have to pick it either the 1 or 2 up here. So we can't pick the second one there again, because then the length will be the same. So you can only actually pick this one, or you can pick this one. So there's only 2 choices, 2 triangles you could make. And it's the same for every edge on the outside by symmetry, and there's 4 of those. So there should be 8 triangles you can make with the long horizontal vertical sides. Okay, but you could also take the sides in the middle. And the middle ones have the extra possibility of doing 2 on each side. Okay, so if you do 2 on each side, there's 4, and since there's 2 middle edges, the vertical and horizontal, times it by 2 to get 8. Okay, so these altogether should be 16. And then, okay, so then if you don't have a long side or a long diagonal, there's only, well, we said there's only 5 different side lengths. So then the other triangles have to have exactly one of these short distances, the diagonal distance, and the right line. Okay. And so let's have a look. So if it's on the edge here, that's a line. Then to get the third vertex of the triangle, you can't go too far because you don't have the long diagonals. You can't go like here because then you get an isosceles, so you have to go up and down with a night line. It's the only thing you can do. Okay. So there's a one triangle for each of these little, like the short vertical line or horizontal line, and by symmetry it's the same for each one of those on the edge. So it's 1, 2, 3, 4, 5, 6, 7, 8. So there should be 8 triangles that look kind of like this. Okay. And then there's the ones that are in the middle. Okay, so there's one in the middle. You can go both ways, up there or that way. You know, you can't go anywhere else without making it either long or isosceles. Okay, and then there's 1, 2, 3, 4 of these types of edges. So this is times 4. 2 times 4 is 8, plus 8 should be 16. So there's actually quite a lot of triangles. 32 plus 8 is 40. Okay, I haven't had time to check this. Hopefully this is right. If you see something wrong, please let me know.